Hi, I'm Franz Pear with Cyber Skyline, and today we're going to be learning about magic bytes, which are also known as file signatures and what they do. Now, before we go to magic bytes, we need to quickly cover file types. The background on that is that all files are stored as binary data, regardless of what they actually represent. So whether those are images, PDFs, Word documents, they're all just binary. So there needs to be some way to identify what type of file something is. So that's the file type. File type refers to the specific standardized format that is used to structure the data within the file. So up here on the slides, you can see a couple of examples. Sorry, this is mirrored. That we've got a PDF, a docx, an MP4. So these are all different file types, and each one has a specification, a standard on how the data in that file is stored. And computers use these file types to determine what types of programs can be used to open the file, and app developers follow the specification for the file type to actually read and even write contents of the file. So whether that be if you have a program that will open a image, so a GIF here, or maybe you have an app that will play an MP4, maybe it's a music file. So these file types are very important because if you try to open an image with a music player, that's not going to work, right? That's going to cause an error. Obviously, the contents of an image file are not going to be compatible with a music player app. So that's why file types are so important. So let's go over one easy method to determine the file type for a file. Now, this is a common method, which is using the name of the file itself. And so you've likely seen, if you opened up Explorer or File Finder on either Windows or a Mac, you've likely seen a view that looks kind of like this, where you have your different files. You have a file name here that they might end in docx, PNG, zip. The stuff that's coming after that dot, it's referred to as the file extension, and it's an indicator for the file type. And many operating systems will use the file extension to determine what icon that you can see there on the left side. It'll determine what icon to show there, and also what programs you could use to open the file when you double click on it. So that's all very useful, but there's a catch. So if you think about it, the file type is used to specify like how the contents of the file is structured, right? So an MP3 file is used to specify the structure of the MP3 file, how it should be read, how it should be written, how to play a note, all of those things. And the file name, well, that has nothing to do actually with the contents of the file, right? It's completely independent. You can name a file whatever you want. And in fact, there could be an issue here where if I go and I right click on one of these files, let's just say we're looking at this zip file, I go to rename it and I change the file. So I rename it instead of something, instead of .zip, I rename it with a different file extension, such as .png. And if I save this, what you can see is that the file name will now end in .png, and the icon will also change to an image icon. But all we did was change the name, right? The file, the contents of the file is exactly the same. We didn't do any sort of file conversion. That is something completely different. All we did was change the name of a file. So the data is the same. It's still a zip archive, but the file name says .png. So if we actually go and try to open this file, now that we've renamed it, we'll actually get an error. And this is what you'll see on Windows. And this is my Windows computer trying to open this file using the Photos app, because it has the Photos app pre-installed, and the Photos app knows how to open PNG files. So it'll try to open it with the Photos app, but once the Photos app starts up and it actually tries to follow the PNG file structure and actually read the contents of the file, it will realize that this is not actually a PNG file, and that's why we're getting this error. So this brings up the question, how come the Photos app knows that this is not a PNG file But Windows does think it's a PNG file. Why is that? And the reason for that is that Windows is only using the file name itself. It's not actually looking at the contents of the file, because it's a lot more efficient. Instead of Windows having to actually open up every single file to determine what the file type is, if all it does is just look at the name, it's a lot faster, a lot simpler for Windows to do that. But when you actually go and open it in the Photos app, it actually has to go read the contents of the file and determine the file type itself. So the way that this works is that all standard file types have published documentation that describes how the data is actually structured in the file. And when developers are creating an app that will be compatible to actually read a specific file type, they're going to create code, they'll create functions that will parse out the contents of the file and then use it. And they will create that parsing function by following the public documentation for that file type. So for PNGs, you can go online, you can look up the public documentation for the PNG file type and find the structure of how the data is laid out within a PNG file. And this needs to be done for every single file type that the app supports. So the Photos app, it supports PNG files, it also supports JPEGs, it also supports GIFs, it also supports other files that I'm not even thinking of. And when it attempts to open the file, it's going to loop through all of its supported formats and determine if the file that it's opening, if that file is in the file type of any of its supported formats. And so when we tried to rename our file and the Photos app tried to actually read it and it went through its list of supported formats, it's like, nope, none of these actually match the structure of the files that I recognize. So then we get this error that says, hey, it looks like we don't support this file format. So that is the difference between the Photos app and Windows trying to determine the file type. Windows is just using the name of the file, and the Photos app actually looks at the contents of the file and tries to determine the file type with the contents of the file. Now, to make this process easier for developers, the process of actually identifying, hey, what is the file type here? Many file types use magic bytes. Those are also known as file signatures. And what this is a specific sequence of bytes that is found within the contents of the file, and it's intended to uniquely identify this file type. So it's going to be different from the other public file signatures, the magic bytes of other file types. Now, typically these magic bytes will come at the very beginning of a file so that applications attempting to support this file type, they don't have to go, really deep into the file just to realize that, hey, this file isn't actually using my supported file type. So typically this will come at the very beginning of the file, but note, I say typically for a reason. There is no requirement that a file type has a magic byte sequence or a file signature, or that if it does, that at the beginning of the file. There are no such requirements. It's just common that this is the case. And so what you can do is, for a lot of file formats, you can do a quick internet search and you can find actually the magic bytes for any file type that uses them. So what I have up here on the screen, what you're seeing over here, this is a table that I pulled off Wikipedia that outlines the structure of a zip file. And you can see on the very first line here, we have what is indicated as the file signature. So the first 4 bytes of a zip file should be what it has here. That's the 54B0304. That's what you're seeing over here. And so what we can actually do is, if we pull up a terminal and we run hexdump on our renamed data export PNG file, what we can see is that the file still starts with the magic bytes for a zip file. I have it highlighted here in yellow, the 54B0304. So even though this file ends in .png, it is still a zip file. It still matches the magic bytes for a zip file. And so if we want to be able to open this again, all we have to do is just rename the file .zip. So that way the operating system knows, hey, when I open this file, what program should I use to open it? Because I shouldn't be using a Photos app. I should be using an archive app. And so if you ever run into a situation where you can't open a file, but it has a file extension of a file type that you should be able to open, in this case, we have a PNG file. We should be able to open PNG files on our computer, but it causes an error. So what's going on here? We can look at hex dump, and we can see that the magic bytes in here actually match a PNG file and not, the magic bytes actually match a zip file and not a PNG file. So we're going to actually go and take a look at this firsthand through a demo here. All right, so right now I have a JPEG file, and if I right click on it over here, I look at the properties, it fails to load. So there's already something suspicious here going on with our so-called JPEG file. If I double click on it, you can see we get an error, could not load image flag.jpg. And the reason, it says error interpreting JPEG file, image file, unsupported marker type 0xF6. Okay, so there's some sort of error attempting to read this as a JPEG file. So what I'm going to do is I am going to, there's multiple things we can do to kind of analyze this. You can put this into CyberChef, and if we put it into CyberChef, you can see this ASCII representation here. What's really cool about CyberChef is they have this tool called Magic, which looks at the magic bytes to try to determine the file type of the image. And you can see here that it seems to think that this is a JPEG based on that. Okay. So it seems to think it's a JPEG. So how come it's not actually opening properly? Because if it's a JPEG, it's named JPEG, the magic bytes say JPEG, why isn't this working? So what we need to do is actually pull up the documentation, JPEG file structure. And what we can see here is that there is a marker here. This looks like the magic bytes. The file starts with this sequence. So FFD8, FFE0. So if we go back and we do a hex representation, FFD8, FF. Okay. That looks correct. Okay, so why is it not working? Well, let's look at the rest of the file and see if we can get any other clues. If we run the strings command, we can get some information from some of the metadata in the file, which is text printable. I can see this was created with GIMP, and I can see that this says JFIF. So that corresponds to the magic bytes for a JPEG file. And then I can also see this ICC PICC profile. So if I go and take this and ICC, what is this? PICC profile. If I go and I search for this, let me try to find more information about it. So this is used for identifying colors. So what if I search for file type? So it looks like this is used in multiple different file types, PNG or ISO, sorry, no, PDF, DNG, PNG, SVG. So none of these list JPEG here as the specific embedding format. There's some sort of other specific thing here relating to JPEG. So this might not actually be a JPEG, even with these magic bytes set to that. And it could be an indication that this is corrupted in some way. If I look at some of the other data, so if I look at IHDR, I search for that. This is something that shows up in the PNG specification. If I search for something else that looks not like gibberish, there's also IDAT-X. That looks like it's an abbreviation for something. IDAT-X. This also is part of the PNG specification. So it's possible that this might not be a JPEG file. This might actually be a PNG file, but the magic bytes don't match the bytes for a PNG file. So we will need to go and fix this file and restore the magic bytes so it matches a PNG file so that it can be opened. And so you can do this with any sort of hex editor that you would like. I use Hex Edit as an online tool to help me with the editing, because very quick, it's a GUI and I don't need to install anything. And if I just go to open file here, I have that in here. And if I go and I look for the PNG file structure, actually, let me just look for, there's a Wikipedia list of magic bytes and file signatures. And if I go over here and I search for PNG, these are the magic bytes for the PNG. So let's go and restore this. So when we have the file signature for the PNG, we go in here, put this in. This is 8950 4E 47 0D 0A 1A 0A. All right, now we export it. And then if I go to my downloads, this is the newly downloaded file. I rename it to PNG and I try to open it. So we still get an error, but it's a slightly different error than the one that we got before. So the original file, this said unsupported file marker type. And then with the PNG, with the new magic bytes, we get fatal error reading PNG image invalid IHDR length. So if we go to PNG file format and we pull up the official specification, what we can see here is that the file structure, you have the file signature. This is in decimal. We had our value from Wikipedia in hexadecimal. So these correspond to each other if you do the conversion from decimal to hexadecimal. After the file signature, you have these chunks, chunk layout. Each chunk consists of 4 parts, length a 4-byte unsigned integer. And if we go back over here, that means that the next 4 bytes, these next 4 bytes should represent a number, an integer. Now, this looks like it would be a very large number because reading left to right, having things here would indicate you have a lot of values in the leftmost, the most significant bits. And it's entirely possible that when the magic bytes got corrupted over here for the where they got switched from the PNG to the JPEG magic bytes, those magic bytes are different lengths. So if I look for a JPEG over here, if I go to the JPEG, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 bytes long versus the PNG is 1, 2, 3, 4, 5, 6, 7, 8. So it's entirely possible that these 4 bytes over here got corrupted. They got clobbered, and this is just no good. And that's what's causing the error when we try to read this file. So we have a couple options here. One option is we can kind of use our best guess. We have a 4-byte unsigned integer over here that represents length. We could try to find a more reasonable value for the length. Another option that we have is we could use another PNG file as a reference. So actually, if I take a screenshot and I save that, and I go to my terminal and I look at my screenshots folder, if I run hex dump on the screenshot here, then I can just get the first couple of bytes from this screenshot. I'm going to run this through head, so I just get the top part of it. And if we just copy this, we could just hope that this will be compatible enough and get rid of the corruption so that it's readable with the photo viewer. So this over here, this is the magic bytes for the PNG file. And then following that over here, these are the 4 bytes that we think just got corrupted. So if I go back to my editor, and I just want 3 zeros and then 0D. So 0, 0, 0, 0, like that, and then 0D. And then I export this. And then I go over here to my, okay, so this is the previous one that we tried to fix that didn't work. And this one over here, this is our latest attempt, and we want to rename this to PNG. And then fingers crossed, there we go, it opens up. So this is a harder challenge to go through because it wasn't just as simple as changing a file name to match the magic bytes. We actually had to go and fix the magic bytes for a file and then go and actually restore part of the corruption from the file itself. But what you can see here is that file types follow specification for a reason. And if we can just manipulate the data to get it to work within the structure specified in those file types, then we are actually able to restore this file, even though there were those 12 bytes of data which just got straight up deleted by the JPEG file, the file signature overwriting the PNG file signature. Even though those got completely overwritten, we were able to manually restore this file by inserting in the PNG magic bytes and then looking at either the specification for PNG files to create a new value that would be more realistic for that length field, that 4-byte length field, or what we ended up doing, which was creating our own valid PNG file and then copying the 4 bytes there and hoping that that would be valid enough for the file to be read successfully with a photo viewer. So hopefully you learned something about magic bytes.